Okay, Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So I will give you a very short videos just for introduction of our chapter 4, topic 4, which is the higher order linear differential equations. So in previous chapter 1, we have learned about differential equations, and then we are focusing on the first order of differential equation in chapter 2. Okay, and then in chapter 3 we learn about two basic or two main applications of first order differential equations in the electric circuit dan juga mixture problem. Okay, but then a few examples and exercise on these applications of first order differential equations. Saya akan buat videos dan share dengan awak later for your revision. Okay, because we only discuss a few exercise before, so I think you might need a few more examples, especially on pictures problem. So I will record the videos and share with you later. But we will move first to our chapter 4, which is the higher order linear differential equations. So in chapter 2, we are focusing on the first order linear differential equation. Okay, kita belajar beberapa method untuk kita solve first order linear differential equation. In this chapter, we will see the higher order linear differential equation, but actually later we only focusing on the second order. Okay, tapi kita tengok dulu secara generalnya macam mana form, macam mana bentuk higher order linear differential equations. Okay, so in chapter 1 kita dah belajar macam mana kita nak tentukan order of linear differential equations adalah apabila kita lihat kepada the highest derivative appear in the differential equations. It's not a power of the derivative but the highest derivative that appear. Maksudnya berapa kali differentiation yang berlaku yang paling banyak, yang paling tinggi dalam awak punya equation, itu adalah order of our differential equation. Secara generalnya, we can write the higher order linear differential equation in the form of this one. Okay, in the form of this one, di mana kalau awak tengok, this one is the general form where we have a and x. A and x here is the coefficient for the derivative to the power of ny. Okay, derivative to the power of ny means that this one is n order n. Contohnya kalau saya ada dy over dx, this one is order 1. If I have d square y dx square, this one is order 2. If I have d cube y dx cube, this one is the differential equation of order 3. And if I have d ny dx to the power of n, this one is the differential equation of the power of the order n. Okay, so kalau awak tengok the form of higher order linear differential equation ini, dia punya order berkurang. Okay, dia susun start from the highest sampailah the dependent variable itself. Kalau awak tengok dekat kita punya differential equation ni, dependent variable kita adalah y and independent variable kita adalah x. Okay, dia susun daripada derivatif yang paling tinggi sehinggalah awak cuma ada y sahaja. Di mana y ini bila kita differentiate, kita akan dapat dy dx. Dy dx kita differentiate, kita akan dapat the next derivative, which is d square y dx square. D square y dx square, if we differentiate, we will get the next derivative, which is d cube y dx square, and so on so forth. Okay, so kita susun kita punya differential equation mengikut dia punya order sehinggalah, okay, the last one is the dependent variable itself equal to any function of x di sebelah kanan. So ini adalah the linear differential equation, the form of higher order linear differential equation, where the order ni boleh jadi apa-apa pun lah. Okay, for example, kalau saya ada contohnya 4x d cube y dx cube plus 5d square y dx square minus 3 dy over dx plus 4y equal to 5. This one is one of the example for higher order linear differential equation, di mana kalau awak tengok dalam differential equation ini, our dependent variable is y and our independent variable is x, and the order of our differential equation is 3. Okay, is 3. So this one is the gx, the function of x. Walaupun tak ada x, sebenarnya ada x kat belakang ni to the power of 0. So this one we call as a function of x. Okay, di sebelah kiri kita akan susun derivative sehinggalah the dependent variable itself. Contoh lagi, kalau kita ada 4dx d cube 4d cube x dt cube minus 4dx over dt minus 4 equal to 0. Okay, so you just need to bring negative 4 to the right. So you will have 4d cube x dt cube minus 4 dx over dt equal to 4. So this one is the higher order linear differential equation as well, because we have the derivative to the power of 3. Okay, we have the third derivative, means that our differential equation here is at the order 3, and this one is the gx, because it's only a function of x, is nothing related to the dependent variable. Okay, so this one is the form of higher order linear differential equations. So you just need to bear in your mind that higher order linear differential equation means when we have our differential equation with order more than 1. Okay, bila kita ada differential equation kita bukan first order, itu dah dikira sebagai higher order differential equation. So kita punya differential equation ni, kita tahu dia ada, kalau kita tengok dalam first order differential equation hari tu, kita belajar tentang how to differentiate the homogeneous first order differential equation and non-homogeneous first order differential equation dengan cara kita check dia punya, orang panggil apa, dia punya sifat dia, ada cara dia macam mana kita nak check first order DE itu adalah homogeneous or non-homogeneous. But for higher order linear differential equation, untuk order yang lebih daripada 1, untuk kita tentukan either our higher order linear differential equation homogeneous ataupun tidak, bergantung kepada nilai gx ini. Okay, if the value of gx is equal to 0, means you will have the homogeneous higher order linear differential equation. Okay, maksudnya awak ada differential equation equal to 0, dengan syarat di sebelah kiri mestilah semua yang melibatkan the derivative. Okay, the derivative, and the last one is the dependent variable itself. Selain daripada tu, kita kena pindahkan ke sebelah kanan. Dan bila sebelah kanan ni equal to 0, we call this differential equation as homogeneous higher order linear differential equation. Okay, so katakanlah contoh, saya ada 4d square y dx square minus 5 dy dx plus 4y equal to 3. This one is non-homogeneous. Why this one is non-homogeneous? Because you have here your gx is not equal to 0. So bila you punya gx is not equal to 0, then this one is the non-homogeneous higher order linear differential equation. So untuk jadi homogeneous, mestilah di sebelah kanan ni equal to 0, dengan syarat di sebelah kiri hanya melibatkan the dependent variable dan juga dia punya derivative sahaja. Contohnya, kalau saya ada 4dx over dt minus 3d square x dt square minus 4x minus 5 equal to 0. Okay, jangan simply cakap this one is homogeneous. You need to see first, di sebelah kiri tu betul ke tak betul, ataupun masih lagi ada variable yang kita kena pindahkan. So if you say this differential equation is actually the differential equation yang melibatkan dependent variable x. So, di sebelah kiri hanya perlu ada the variable, the dependent variable x dan juga dia punya derivative. Selain daripada tu, kita kena pindahkan dia ke sebelah kanan. Therefore, if you rewrite your differential equation here, it will be negative 3d square x dt square. Kita susun ikut turutan. plus with 4 dx over dt minus 4x is equal to 5. Therefore, now you have your gx is not equal to 0, so this one is a non-homogeneous higher order linear differential equation. So that is how we want to determine whether our higher order linear differential equation is homogeneous or non-homogeneous. It only depends on the value of gx, so it's differ from the first order differential equation. Alright class, so as we learned before in chapter 2, every differential equation has its solutions. Okay, so kalau dalam chapter 2, when we learn about first order differential equations, okay, when we learn about first order differential equation means that we already have the equation that have been differentiated. Okay, so when we talking about solving, when we are talking about solving means we want to find what is the value of y. Okay, so we will use we learn two method, which is the separable variable method and also the linear equation method, if you can remember. And at the end of the method, we will get the solution in term of y. Okay, so same goes to the higher order differential equation, but you just need to know that when we have the first order when we have the first order differential equation yang order dia satu, you will only have one solution. Okay, but if you have the second order differential equation, you will have two solution, means you will have y1 and y2. Dia sama macam kalau kita ada linear equation. If we have linear equation, contohnya 4x tolak 3 sama dengan 2 yang melibatkan satu unknown, you only have one solution. But if you have a quadratic equation, let's say 4x square minus 4x plus 3 equal to 0, you will have two solutions, x1 and x2. Okay, so the same concept for differential equation. If the order of your differential equation is 1, then you will have one solution. But if you have higher order differential equations, the number of solution that you will get is equal to the order of the differential equation itself. Kalau you ada differential equation with order 3, means that you will have 3 solution. Okay, if you have the order of differential equation at n ini kita tak tahulah. Okay, n ni maksudnya tak tahu berapa nilai n, therefore you will have n number of solution. Kalau awak ada differential equation to the with order 5, okay, maksudnya ada 5 lah solution awak. Okay, so that's why we have a superposition principle that tell us about the solution, where if you can read here, dia kata let y1, y2 and yk be a solutions of the homogeneous n order differential equation on an interval I. Okay, bukan n order, sebab kat sini dia guna k, means that it's k order. Okay, because you have your number of solution mestilah sama dengan order of your differential equations. Okay, dia kata y1, y2, yk adalah solution untuk kita punya homogeneous. This one is focusing on homogeneous, where homogeneous maksudnya awak punya gx equal to 0. Okay, let y1, y2 and yk be a solutions for your homogeneous k order differential equation on an interval I. Then the linear combination y equal to c1 y1 plus c2 y2 plus ... plus ck yk. Okay, sini silap kita guna k, so semua kena guna k lah. Okay, so sini k. Okay, ck yk, where the ci are arbitrary constant, so ci ni hanyalah constant. Okay, is also a solution on the interval. Maksudnya adalah if we have second order, for example, kita ada differential equation to order 2, means that we will have y1 and y2, dua solution. Okay, so the combination of these two solution, where we will get y equal to any constant C darab dengan solution yang pertama tambah dengan any constant C darab dengan solution yang kedua, the whole thing here is also called as a solution to our differential equation according to the superposition principle. Okay, di mana superposition principle punya idea, it give us the fact that the sum of any n solution of higher order differential equation is again a solution. Okay, means that if we have the differential equation with order 5, so we will get 5 numbers of solution. So the combination of all 5 solution is again also a solution, where we combine all the solution that we have so that we come up with only one last solution. Okay, maksudnya Y dia, solution yang terakhir adalah solution pertama tambah dengan solution kedua, tambah solution ketiga, tambah solution keempat, tambah dengan solution kelima. Okay, dan if you have any constant yang darab dekat depan solution ini pun kita consider dia sebagai again a solution to our differential equation according to superposition principle. Okay, so apa yang you kena ingat adalah the number of solution that we will have for our differential equation is according to the order of our differential equation. If we have first order, then we only have one solution. If we have second order, then we have two solutions. If we have n order, then we have n number of solution. And the combination of all solution is also a solution according to the superposition principle. So superposition principle ini adalah theorem. Okay, therefore we have a corollaries, where corollaries ini adalah supporting statement to the theorem. Okay, corollaries mengatakan bahawa a constant multiple y C, Y, X, maksudnya kita punya solution adalah Y1. Constant multiple maksudnya solution kita ini didarabkan dengan any constant, okay, of a solution Y1. So Y1 tu solution of a homogeneous linear differential equation. We are now focusing on the homogeneous differential equation is also a solution. Macam saya cakap tadi lah. Okay, kalau kita ada 3 solution, Y1, Y2, Y3. Okay, ketiga-tiga solution ni kita darab dengan constant. Constant yang pertama, constant yang kedua, constant yang ketiga, and then kita tambahkan semua sekali, C1Y1 tambah C2Y2 tambah C3Y3. Keseluruhan ini dipanggil sebagai solution to our differential equation according to superposition principle. And then the corollaries number 2 said that a homogeneous linear differential equation always possesses the trivial solution y equal to 0. Maksudnya, y equal to 0 also known as a solution to the differential equation. Okay, so itu adalah how we want to determine whether our higher order linear differential equation is homogeneous or not, where it depends on the value of gx here. If it's equal to 0, then it's homogeneous. Okay, and then now we are focusing on the solution of homogeneous differential equation, di mana solution itu bergantung kepada berapa order kita punya differential equations. Number of solution itu ikut order, dan the combination of all solution is also a solution according to superposition principle. Okay.